Hello guys, my name is Nicholas Massa, and today I'm going to be showing you how to make your very own Lunar Reconnaissance Orbiter, or LRO for short. So, what's the point of an LRO? So scientists and engineers have worked alongside each other to build and design NASA's LRO. Scientists use tools to take measurements, observe, experiment, and to explore. Many of these tools measure things that humans cannot see, smell, taste, feel, or hear. The LRO has different instruments on board to collect information about our moon. It has cameras for taking detailed photographs of the surface to help engineers select future sites for lunar outposts. Other instruments detect different wavelengths of light reflected from the surface to help identify and map resources. It carries a laser to map the elevation of the lunar surface in great detail. It also has sensors to gather information about lunar surface temperatures and radiation levels. Science helps technology improve, as we all know. The LRO carries many new instruments and some that are improvements on previous designs. There's always a balance between what scientists would like to test and what is possible, however. Many instruments were proposed by different teams of scientists and engineers, but not all could be selected, because the spacecraft has limited amount of space for the instruments to be mounted. It can carry only a certain weight, and there is a limited budget for developing instruments. Technology like the LRO is created to serve a purpose. The LRO's goal is to identify and map lunar resources, possibly including water ice. Alright, so some materials you're going to need before we start this are copies of the LRO spacecraft images. You don't want to print those out. I have some right here, as you can see. A couple different images. Alright, now these are going to help you design and create your LRO. And there's two different models you can design. You can design the edible model or the non-edible model. And I've chosen to go with the non-edible model due to the resources that I have. Alright, so for the edible model, you're going to want toothpicks, a small containers of marshmallow cream, spoons, candy, cookies, and crackers of varying sizes and shapes. Alright, these are all to build and design your LRO. And you really want it to be your very own, right? So you're going to want to really imagine and create this spacecraft. Now for the non-edible model, you're going to want tape, glue, aluminum foil, and different craft items such as pint-sized milk containers, coffee cans, soup cans, and other objects for the spacecraft body, and different devices mounted onto it. Okay? So, you're also going to want to print out the LRO's eyes, ears, and other tools sheet, which will be provided in the link. Okay, so how about we get started? Because it's expensive to send humans, it is important to learn about the moon with robotic explorers. These robots aren't like those we see in the movies. They don't have eyes, hands, and legs, but rather there are spacecrafts that have many instruments pointed at the moon's surface to look for water, ice, and elements and rocks. And they map where the surface is safe for landing and building, and find where scientific questions about the moon's formation and changes can best be studied. All these activities will prepare future astronauts. Alright, so I'm going to ask you a few questions, and you want to think about these when you're designing your LRO. What tools do you use to explore? Alright, so you're going to have eyes, ears, noses, sense of touch, and taste, which can include cameras, thermometers, flashlights, magnifying glasses, etc. And these are all to discover more about our planet, our moon rather. Alright? So, also, in what ways are robots such as our spacecraft different from human explorers? Right? So, to start, they don't need to eat. They do need power from solar panels or batteries. They are stronger, and they are better able to withstand the radiation, cold, and heat in the vacuum of space. They can't think for themselves, and they are not creative, right? So we have to tell them what to do with antennas and program their computers, okay? And because the orbiters operate from such a high, they operate high above the moon's surface, they won't be able to mimic the sense of touch or taste. And with no air for sounds to pass through, there is no need for ears. They are, however, able to see, with different kinds of eyes that can detect types of light that are not visible to human eyes. Spacecraft use the light of sun and stars, which reflects off the moon's surface, okay? In addition to their own lasers and radars to see, okay? So, think, what different parts do you need, okay? Obviously, you're gonna need to start off with the body, right? This body's gonna need to be able to hold and withstand the weight of the instruments, right? Engineers call this a platform, right? It needs to be able to hold the solar panels, okay? You're gonna need solar panels for energy, okay? You're going to need communications so you can report back to Earth and also receive program, okay? You're also gonna need shiny film to shield the spacecraft, all right? And this can be your aluminum foil or whatever you really design it to be, all right? So think, are the instruments spread out or crowded in a few places? The instruments must have a clear view of the lunar surface. So if they're bunched up and crowded, they're not going to be able to see very well, okay? So keep that in mind. What kind of information will the LRO collect for scientists, right? So its cameras, lasers, and radars are helping the LRO make maps, right? But they are also looking for certain types of rocks that can be used by human explorers to make oxygen to breathe and fuels. And they hunt for clues of water ice, all right? Its own special nose, called a neutron detector, is sniffing out hydrogen and may help scientists find water, which is 2 parts hydrogen and 1 part oxygen, or H2O. Okay? LRO has its own night vision goggles. That's pretty cool. Okay? And they will help the spacecraft see ultraviolet light reflecting off the surface from starlight. Other instruments see different types of lights coming from the sun, some of which may harm humans. One instrument is measuring how much these types are shining onto the moon's surface. A special type of thermometer will find cold spots on the moon that may hold water ice, like a lunar freezer, and measure the daytime and nighttime temperatures. So, future explorers will need maps of the moon to help find smooth places to land and build habitats, and to find resources like types of rocks and water ice. LRO's instruments will show scientists features as small as a 1.5 foot across. That's really small from how high up they are. So now I'll invite you to build your very own lunar reconnaissance orbiter, all right? Think of what you will use to power your spacecraft. How will your spacecraft move around? And what tools will your spacecraft will use to explore the moon? How will it report back to scientists on Earth? These are all questions you want to keep in mind when designing it, okay? So, as we know, NASA's scientists and engineers work together to plan, build, and launch the LRO. They too had to decide what tools to give the spacecraft. Many instruments were proposed by different teams of scientists and engineers, but not all to be selected, as we said before, due to space and weight. Okay? Alright. Now, you're going to want to gather your resources and start building your own LRO. For the sake of time, I've built my own already. You can kind of see that. I have different instruments on it, okay? Now, the image that you will be able to print out should really help you build your LRO, okay? It has different things to tell you what is what. So you see right here, I have a solar panel. I have my high gain antenna system off to the side. I have my thrust modules at the back so I can boost. I have my neutron system, and there's multiple instruments that I've included onto here to really help explore and map the moon. All right, so give it a go and try for yourself.